Classmates, last lecture, we studied how comparative advantage functions in a world with two goods. In the real world, each country may produce lots of product. To move closer to reality, today we will extend the model to a larger number of goods and focus the following issues. First, setting up the model with many goods. Second, relative wages and specialization. Third, determination of relative wage with many goods. Fourth, comments on comparative advantage theory. Next, we will discuss these issues one by one. First, setting up the model with many goods. Again, imagine a world of two countries, home and foreign. Each country has only one factor of production, labor. However, let's assume that each of both countries consumes and is able to produce a large number of goods, say n different goods altogether. We assign each of the goods a number from 1 to n. The technology of each country can be described by its unit labor requirement for each goods. That is, the number of hours of labor it takes to produce 1 unit of each good. We label Holmes' unit labor requirement for a particular good as ALI, where I is the number assigned to that good. For instance, 1 is assigned to the number of 6. AL6 will mean the unit labor requirement in wine production. We label the corresponding foreign unit labor requirements ALI star. For many goods, we can calculate ALI over ALI star. The ratio of Holmes' unit labor requirement to foreigners will label the goods so that the lower the number, the lower this ratio. That is, we rearrange the order in which we number the goods in such a way that AL1 over AL1 star less than AL2 over AL2 star is less than AL3 over AL3 star, and so on. Second, relative wages and specialization. Let W and W star be a wage rate per hour in home and foreign respectively. The rule for allocating world production then is simple. Goods will always be produced where it is cheapest to make them. The cost of making goods 1 equals the unit labor requirement times the wage rate. So to produce good I in home will cost WI times ALI. To produce the same good in foreign will cost WI ALI star. It will be cheaper to produce in home if WI ALI is less than WI star ALI star, which can be rearranged to yield ALI star over ALI exceeds W over W star. On the other hand, it will be cheaper to produce the good in Folin if WI-ALI exceeds WI star times ALI star, which can be rearranged to yield ALI star over ALI is less than W over W star. Thus, we can restate the allocation rule. Any good for which ALI star over ALI exceeds W over W star will be produced in whom, while any good for which ALI star over ALI is less than W over W star will be produced in Folin. Table 1 offers numerical example in which whom and Folin both consume and are able to produce 5 goods: apples, bananas, caviar, dates, and enchiladas. The third column is the ratio of the Folin unit labor requirement to the whom unit labor requirement for each good. For instance, for bananas, ALI star over ALI equals 8. Whom will have a cost advantage in any good for which its relative productivity is higher than its relative wage. So does Folin. If, for example, the whom wage rate 5 times that of Folin, W over Folin star equals 5. Then the apples and the bananas will be produced in whom and the caviar, dates, and the enchiladas in Folin. If whom wages is only 3 times that of Folin, whom will produce apples, bananas, caviars, while Folin will only produce enchiladas. Is such a pattern of specialization beneficial to both countries? We can compare the labor cost of producing a good directly in a country with that of indirectly producing it, producing another good, and trading for desired good. If the whom wage rate is 3 times the free wage, whom will import the dates and enchiladas? A unit of dates requires 12 units of foreign labor to produce, but its cost in terms of home labor is only 4 person-hours, which less than the 6 person-hours it would take to produce the unit of dates in whom. A similar calculation will show that Folin also gains. For example, a unit of apple requires 1 unit of whom labor to produce, but its cost in terms of foreign labor is only 3 person-hours, which is less than 10 person-hours it would take to produce the unit of apple in Folin. So both trading nations gains from trade. Third, determination of relative wages with many goods. But how the relative wage are determined? We also need to draw relative supply curve of labor, RS, and the relative demand curve of labor, RD. The demand for labor is a derived demand that results from the demand for goods produced with each other's labor. The relative derived demand for home labor will fall when the ratio of home to foreign wages rises. If the home wages is 3.5 times the foreign wage, home would produce apples, banana, and caviar, while foreign would produce dates and enchiladas. If the relative home wages were to increase from 3.5 to 3.99, the pattern of specialization would not change, but as the goods produced in home become relatively more expensive, relative demand for these goods would decline. The relative demand for home labor would decline with it. Suppose now that relative wage were to increase slightly from 3.99 to 5.01. This small further increase in relative home wage would result in pattern of specialization changing. The production of caviar shifts from home to foreign. So there is another abrupt dropping off in the relative demand. So the curve oscillates between monthly downward sloping sections where the pattern of specialization does not change, and flats where the relative demand shifts abruptly because of shift in the pattern of specialization. These flats correspond to relative wages that equal the ratio of home to foreign productivity for each of 5 goods. The relative supply of labor is determined by the relative size of home and foreign labor forces, assuming that the number of person hours available does not vary with wage. The relative wage has no effect on relative labor supply, and the RS is a vertical line. The equilibrium relative wage is determined by the intersection of RD and RS. The outcome depends on the relative size of the countries, which determines the position of RS, and the relative demand for the goods, which determines the shape and the position of RD. If the intersection of RD and RS happens to lie on one of the flats, both countries produce the good to which the flat applies last, comment on comparative advantage theory. Until now, we have understood that if a country follows its comparative advantages, it can gain from international trade. But there are 2 points we should note. First, the patterns of comparative advantage can and do change over time. For instance, in the early 1800s, the United Kingdom had a comparative advantage in textile manufacturing. Then that advantage shifted to the New England states of the United States. Then the comparative advantage shifted once again to North Carolina and South Carolina. Now the comparative advantage resides in China and other low-wage countries. Let us see how changing comparative advantage relates to our trade model. Figure 2 illustrates the production possibility schedules for computers and the automobiles of the United States and Japan and the conditions of constant opportunity cost. Note that the opportunity cost of automobiles into computers initially equals 1 for the United States and 2 for Japan. The United States thus has a competitive advantage in production of computers and a competitive disadvantage in auto production. Suppose both nations experience productivity increases in manufacturing computers, but low productivity change in manufacturing automobiles. Assume that the United States increases its computer manufacturing productivity by 50% from 100 to 150 computers, but that Japan increases its computer manufacturing productivity by 300% from 40 to 160 computers. Because of these productivity gains, the production possibilities schedule of each country rotates outward and becomes flatter. More output can now be produced in each country with the same amount of resources. Referring to the new production possibility schedules, the opportunity cost of automobiles into computers equals 0.67 for the United States and 0.5 for Japan. The comparative cost of a computer in Japan has thus fallen below that in the United States. For the United States, the consequences of lagging productivity growth is that it loses its competitive advantage in computer production. But even after Japan achieves competitive advantage in computers, the United States still has competitive advantage in autos. The change in manufacturing productivity thus results in a change in the direction of trade. The lesson of this example is that producers who fall behind in research and development, the technology and the equipment tend to find their competitiveness dwindling. As competitive advantage change, producers need to hone their skills to compete in more profitable areas. Second, some developing countries may fall into the competitive advantage trap because developing countries usually has current competitive advantages in producing primary products, minerals, agriculture, and labor-intensive products. If they completely follow their competitive advantage, their trade structure will always be low. Also, they obtain benefits from the trade. They always at a disadvantage compared with developed countries, which mainly export technology and capital-intensive products. So the developing countries need to foster new competitive advantages. They should invest in some high technology and capital-intensive products, and then their trade structure may be improved. That's all for today. Thanks for your joining. See you next time.